So the factory of the future for the process industry, vision by SFGP. Just to start, maybe a few words on SFGP, so the French Society of Chemical Engineering, what we call our raison d'être. So SFGP, very quickly, is a network of academic and industrial experts. I would say that's the strength of this organization, academic and industrial. So we are gathering more than 500 people from the French universities in chemical engineering, and also from the industry and from diverse economy sectors, chemicals, pharmaceuticals, energy, food industry, and so on. So we are committed to addressing major societal challenges, such as energy transition, employment. And I would say that our main work is to promote scientific animation in the field of chemical engineering. And for instance, we have, I would say that the living heart of SFGP is our working parties, organized by expertise mainly. And every 2 years, we organize our national congress. Latest one was in Nantes in 2019. And so we are also trying to attract talents to chemical engineering. For that, we have recently set up an annual award for the SFGP PhD Prize. And we are also working on education to develop new training tools and to communicate towards the younger to promote chemical engineering. So what are the process industry, what does the process industry face today for the factory of the future? I would say that the process industry, of course, is facing the digital transformation. So everyone is hearing many transformation about big data, artificial intelligence, 3D printing, and so on. So process industry has to take into account this digital transformation. Of course, speaking of industry, speaking of chemicals, speaking of factories, we have an environmental responsibility to limit global warming and to give an answer to resources scarcity and to manage the water scarcity, the energy, and so on. And we are trying to go toward the circular economy and the carbon neutrality. Of course, when we are talking of the future of our chemical factories, we have to develop higher performance in our plant. So it means that we must be more efficient with regards to energy. Maybe we have to be more efficient in the economy of the design, going to modular design, for instance. And we do think in SFGP that process intensification is the right tool to get this performance. And then maybe the main thing we have to face is the societal acceptance, especially in the Western countries. So we have to manage the risk to be sure that everything is safe in our plants, everything is safe as regards the data also, and that we are developing a sustainable economy. And maybe our present challenge, the main one, is to prove there is a future for process industry in European countries in the Western world. So to answer these challenges, SFGP set up a commission Usine du Futur, the factory of the future. So the context of this commission was the launching in France of a new organization about Industrie du Futur, Alliance Industrie du Futur, in 2015. But actually, this organization mainly deals with the manufacturing industry and not the process industry. That's the key point in my speech today. We also developed a white book on the renaissance of the French process industry, organized in 2017, Assizes of Chemical Engineering, just to explain to our policymakers what strength we have in this area. And so from this context, we edited this white book on the French chemical engineering in 2017. And this book is available in English since 2018. You can have it on our website also. And then in this context, we decided to set up a team, a real project team in SFGP to work on this vision of factory of the future. So I presented in this slide the main people from this team. As you can see, many companies were part of the work, and companies from the different sectors: energy, Total, from the gases, air liquide, from the chemical industry, of course, Arkema, Solvay, from the pharmaceuticals, Sanofi, and from the environmental services, Veolia. So that's a key point of our work. The companies, the industry is mainly involved in this in the project. Then we also involve companies from the engineering area, so ERAS, and also from the equipment suppliers. And we have several business associations, French business association, part of the team also, as you can see, CETIM, ANIA for the food industry, CETIM for the suppliers of equipment and so on. And of course, the universities of chemical engineering are also part of the team with the two main universities in France in chemical engineering, Toulouse and Sasset, and Nancy and SIC. So this is a real project team, and our project leader is Dominique Orbez, the vice president of SFGP and also part of the Solvay company in the chemicals. And so the production of this team is our white book on Usine du Futur for process industries, and you can have it on our website. So today, I will try to give you a taste of this work, of this white book, and to present you what we gathered in this in this book. So the first part of this book is to define in what context the process industries is today. So what are the main challenges, and we showed that the factory of the future, in our opinion, is currently under construction. It's already in progress. And then we define what are the main issues we have to tackle today. And then we decided to present a few examples. And today in my speech, I've picked up a few examples from our white book to give you a taste of it. So what is the application of digital in process design? What are the application of digital in process operation? How to develop eco-efficient processes? And what does the process intensification gives to the performance of the new factories? And then one big part of our work deals with the education. And we do think that to develop this factory of the future, we also have to evolve, to make the education evolve from the chemical engineer. And then with the conclusion, SFGP vision. So now, a few examples I present very quickly in this page. So first thing, for the design of the process industry, we require basic data acquisition. And in this field, we have also to design maybe new lab tools to make this basic data acquisition for design, to make sure that the scale up is efficient, and to make sure that our plants will be profitable, economic assessment, and so on. So in the white book, we give a few examples. So from EFP, for instance, on the right of the slide, with high throughput data acquisition, giving data for the catalytic processes, for instance. Another example in the digital is the use of digital in process design. So today, of course, engineering, as many other areas, is open to the new tools in the digital transformation. And you will have in the white book a few examples. Of course, if you have to design a new plant in an existing facilities, you can use 3D scan to make sure that everything will plug in. But I would say in the design, the Google vision, the 3D scenarios are very useful. And in my personal experience, I can tell you that when you have to design a new pilot plant facilities that you have to send in foreign countries, it's very useful to use this 3D vision to make the design. And of course, these tools are very useful for the training of operators when commissioning the plant. But I would say that the digital is is even more useful in the process design, I would say linked to the modeling of a process, and maybe linked to the 3D printing. So 3D printing, we have a one-day event in this area, can link to very specific geometries of reactors. And for instance, from Air Liquide, we present an example of a pressure reactor which has been designed directly from modeling and then constructed through a 3D printing system. Then I would say that digital is also present in process operation. And as I put it in this example from Solvay, the Z generation is now in our factories and is expecting to use the same tools as we are using at home. So I would say, for instance, in this example of a plant of Solvay, the application used for the maintenance of the plant has been directly designed by the operators themselves. So I would say from different tools, they can make up this dashboard mainly useful for them. So I would say today we have to organize our operation with those tools. Another example from this is from Total, where a monitoring platform has been developed from real toolbox, and there again, this is real-time dashboard, and the one main advantage of it is that you can share the same level of information between the different teams. So from the production, from the maintenance, from the R&D maybe. In the same area, in process operation, I can give you an example from Veolia. We have developed a hubgrade, which is this control room which controls different plants. So we have a vision on the whole territory. And for instance, for the drinking water production, you can optimize the production from one plant to the other one. And if any issue in a plant, ask for the other one to give the water to the population. And so this very efficient tools leads to improvement in the efficiency of the production. Then, of course, the factory of the future will have to develop eco-efficient processes. And there is an example in the area of the energy transition, example of a methanization unit in the food industry. And I would say in this example, it shows that the design of this reactor of methanization is also integrated with the whole energy production on the area with photovoltaic plants, for instance. So and I would say that energy integration is part of the chemical engineering tools. And then to finish in my example, process intensification, which is a main area of the chemical engineering. And I would say this process intensification is a tool to enhance performance and quality control by a design based with a reaction to control. And we have an example from the pharmaceutical sector where a new chemical route has been assessed on a brand new reactor. You can see on the right side of the slide the silicon carbide plate, which is a new reactor for the pharmaceutical active ingredient. And I would say so a whole design to make the control of a reaction on a very new type of reactor, which is now produced by Corning. So as you saw, there are many examples proving that the factory of the future is in progress. And another big part of the reflection set up by SFGP is the education. So what role is expected from a process engineer in the factory of the future, on what training we have to set up for a process engineer. So I won't be long on this part, as it will be presented by Eric Scher in our next webinar next week. But just to tell you today a few actions that are in progress within SFGP. So first one is we are developing innovative and interactive education program. We're also preparing undergraduates for the management of complex problem on analysis of big data, on artificial intelligence. On top of that, we are also trying to make our discipline, chemical engineering, better known and more attractive to younger students, even in the secondary school teachers' action. Then, it's now the conclusion. So I would say, I would try to give you a definition of a factory of the future by SFGP. So I would say that part of the circular economy, the factory of the future will be flexible and will adapt to changing needs, energy transition, and variability of bio-based or recycled raw materials. Based maybe on modular equipment when relevant, it will use additive manufacturing for the production of new equipment and process intensification for the design. Of course, it will be digital and will make full use of the opportunities offered by equipment connectivity, computing capabilities to propose new process control strategies and to develop predictive models for equipment maintenance and to optimize production flows. And then it will be more responsible, environmentally friendly, and economical in terms of natural resources, raw materials, water, and energy. So we do think that process engineering is a key part of the equation. And we do think that solution must be international, and we have new paradigm to develop. Maybe new organization of the production at the level of a territory with a multi-scale integration to get the performance. And maybe this present sanitary crisis may be an opportunity to develop this factory of the future. So thank you for attention, and we're now open to question if time is okay. Thank you to all.